Hello and welcome to the next quickfire question quiz. This time we're looking at the topic B3. So we've got 50 questions. A few of these towards the end are for triple science only. So if you are double science, combined science, then you will have a slightly shorter quiz today. Quite a short topic, infection and response. And let's start with our first question. Remember, if you need to do some revision, there's a playlist complete with the whole topic. Just head to my YouTube channel. So question 1, what is the general term for bacteria, viruses, fungi and protists? What is the general term for bacteria, viruses, fungi and protists? One word answer. And the answer is, of course, pathogens. Key stage 3, we tended to call them microbes or microorganisms. We get into key stage 4 and we start calling them pathogens. Question 2. What process do bacteria use to reproduce? We came across this in B1. We have had this question in the B1 quickfire question quiz, and we're now looking at it again. So what process do bacteria use to reproduce? The answer is binary fission. It's not mitosis, okay? It's not the cell cycle. It is in fact binary fission. Question 3. How are pathogens spread? Now we've got 5 possible answers here. Decide for yourself how you want to do your marking. Are you going to try and look for 5? Are you going to try and get 1 or 2? You decide. So how are pathogens spread? Very topical at the moment. I'm sure we can think of some examples. And here we go with the answers. So we've got airborne droplets, coughing, sneezing, face masks wearing. We've got direct contact, so you directly touch somebody. We've got indirect contact, you touch your door handle, they touch the door handle and it passes that way. We've got through food and water, and we've got through insect bites such as malaria. Okay, that was how a pathogen spread. Moving on to question 4 now. What type of pathogen causes rose black spot? So we have 7 diseases that we need to know about in this topic. One of them is rose black spot. What type of pathogen causes rose black spot? Is it a bacteria, a virus, a fungi or a protist? And the answer is, it's a fungi. Question 5. What disease has symptoms of a red rash and fever? What disease has symptoms of a red rash and fever? Think about the 7 diseases. And the answer is measles. Okay, usually vaccinated against that at a young age. Question 6. What type of pathogen causes gonorrhoea? What type of pathogen causes gonorrhoea? You see this topic, I decided to go in a much more logical format rather than jumping around with the questions. We're going in themes. So which type of pathogen causes gonorrhoea? And the answer is, it is a bacteria. So it can be treated using antibiotics. What disease is caused by a protist? I've already said this one in this quickfire question quiz. So what disease is caused by a protist? It tends to be the protist that everybody forgets. They know the name of the disease, but they forget it's a protist. The answer is malaria. Okay, moving forward, question 8. How is rose black spot spread? So how does rose black spot, those patches of purple and red spots on the leaf of the rose plant, spread from one plant to another? There's 2 ways. And the answer is by wind and water. Moving on, question 9. How is tobacco mosaic virus treated? Okay, we get this mosaic mottled appearance of the leaves. And what can be done? It's a virus. What can be done to treat that? Is this a slight trick question? If it was rose black spot, we could spray it with a fungicide. Okay, and that would treat it. Is this a slight trick question? Also affects the plant, but it's a virus. Okay, the answer is the leaves are removed, destroyed or burned. So I guess in some ways it's not really treating it, it's just stopping the spread. Okay, so slight trick question there. It's just stopping that from transferring to other parts of the plant and also onto other plants. Okay, it's now pouring with rain, so I suspect you'll be able to hear that in the background of this video. Question 10. What drugs would someone with HIV be given? What drugs would someone with HIV be given? Okay, HIV, so it's a virus. I tend to think of it as a virus that was a big problem when it first came about, particularly in the 80s. Now it's very well treated. We've actually had a couple of cases now with people with such low amounts of it that they have been declared free of HIV, which we never thought was going to happen. So what is it? So it's kind of an old school virus, shall we say? Okay, and it's a viral. Let's go for the answer. Antiretroviral drugs. Okay, so we're anti it, we don't like it. It was a real problem in the 80s, and that's retro. If you have some trainers from the 80s, you'd call them retro trainers. Viral because it's a virus, and they're drugs because they are chemicals that we're taking to control it. Okay, HIV attacks the immune system, so this it weakens the immunity, so the antiretroviral drugs try to stop that in its tracks. Okay, question 11. What is done to poultry, that's chicken, in this country, the UK, to prevent salmonella? So salmonella is a bacterial pathogen, causes food poisoning. What do we do to the chickens in this country to prevent that disease from spreading to humans? And the answer is vaccination. We actually vaccinate the poultry, vaccinate the chickens, so that they don't pass that salmonella on to humans. Question 12. What are some of the physical barriers to preventing pathogens entering the body? Again, multiple possible answers here. Okay, what are some of the physical barriers to preventing pathogens entering the body? Think about those sorts of things that stop the pathogens actually getting into the body. Let's look at the answers. Earwax, eyelashes, salt in the tears makes it antiseptic, changes the pH so it's not as easy for the pathogens to live there. Skin, scabs, saliva, these are just a few. There's lots and lots of possible answers that you've got for preventing the pathogens entering the body. Question 13. What is a mosquito referred to as it transmits malaria? What is a mosquito referred to as it transmits malaria? Okay, so the mosquito actually isn't infected with malaria. It is just a transporter, if you like, of the disease from one person to another, and we give it a particular name, and that name is a vector. Okay, it's a vector, just transports it from A to B. Question 14. What are the functions of both a goblet and ciliated cells? Okay, so they work together. Give you a clue, they're found in the trachea, that's the windpipe. We also have ciliated cells along the oviducts. Okay, they move the eggs from the ovaries into the uterus, but that links more to B5. But we've got them in the trachea. Okay, goblet cells do one job, ciliated cells do another job. And what are those two jobs? Okay, let's have a look at the answer. So goblet cells make mucus, that's trapped dust and bacteria. Okay, well, you would call it snot probably. And the ciliated cells waft that mucus away from the lungs, okay, so that it doesn't collect in the lungs. Okay, so we've got the mucus trapping any dust and bacteria that we've breathed in, and then the ciliated cells with little hairs on the end called cilia waft that mucus away from the lungs so that that dust and bacteria don't make their way into the lungs. Okay, question 15. Where in the body would you find a virus? Where in the body would you find a virus? Okay, we're looking in a small scale here. We're not talking about a large scale, we're looking at small scale. Where would the virus be found? And the answer is inside body cells. Okay, that's why, I don't want to link too much to a question we've got coming up, but that's why the antibiotics can't get there, because they can't get inside the cells where those cheeky viruses choose to reproduce. Okay, question 16. What do white blood cells do to fight pathogens? We've had this in a previous quiz, but it's very specific to this topic. So what do white blood cells do to fight pathogens? And we've got 3 methods that we can look at for this one. Okay, 3 different functions of the white blood cells. Try and go for those keywords. And the answers are engulf, so that's surround, and then ingest, and actually digest the pathogen using enzymes. That process there is called phagocytosis, and that's because it's done by the phagocytes, okay, which are a particular white blood cell that have adapted to or specialised in that way to do that process. Release antitoxins that counteract the toxins. Okay, used to say neutralise, exam board tends to say counteract now. So the pathogen will release toxins. This one doesn't attack the pathogen itself, it just gets rid of those nasty toxins using antitoxins released by the white blood cell. And the third one is release antibodies. These particular white cells are called the lymphocytes, and they attach to the antigens. And if you remember, antigens are kind of like little markers on the pathogen that kind of, like a little name tag, they say, you know, I don't know you, you're not part of me. And so because there's that foreign body there, the white blood cells then start to attack. Antibodies latch on to those antigens. When all of the antigens are kind of blocked off, then that pathogen can't cause us any more harm. Okay. Question 17. What kind of immunity is it when you make the antibodies for yourself? Self? Either by being infected or receiving a vaccination. So you can become this kind of immunity when you've either been infected with the disease or you've received a vaccination to give you immunity to a particular disease. So it sounds like you're doing it for yourself. That's a clue in the question. What kind of immunity would we call that? And the answer is active immunity. When we're actively doing something ourselves, we call it active immunity. Next question, 18. What happens if bacteria enters the stomach? What happens if bacteria enters the stomach? Okay, what's in the stomach and what's it going to do to that bacteria? The answer is bacteria are killed by the pH 2 hydrochloric acid. Very strongly acidic there, kills most bacteria. In the situation of salmonella and food poisoning, there's just so much bacteria, the hydrochloric acid can't get rid of all of it, okay? But on a day-to-day basis, the hydrochloric acid kills bacteria that get into the stomach. Question 19. What kind of immunity is it when you rely on a large animal, maybe such as a horse, to make the antibodies for you and then have them injected? This is where we were talking about antivenom. We have a snake bite, we can't make the antibodies, so we rely on a larger animal to be they're not actually just going to put a snake on it, but they give it some of the venom and then it learns how to make those antibodies. We extract those antibodies from that animal and we inject them, okay? So we're not doing it ourselves, okay? When we did it ourselves, we called it active immunity, but we've got something else doing it for us, and the answer is passive immunity, okay? So the larger animal is going to make those antibodies and then we're going to have the antibodies directly given to us, okay? Question 20. Why do new strains of a disease spread quickly? Why do new strains of a disease spread quickly? So the new strain occurs because the original disease has mutated, and we say that it creates a new strain. Why would that spread quickly? And the answer is because no one is immune. So if no one's got any immunity yet, because it's just become that new strain, it means that it will pass quickly from person to person as everybody is able to get that disease as they have no immunity. Okay, question 21. What is found inside the vaccine injection? What is found inside the vaccine injection? And the answer is, classic exam board answer here, a small amount of dead or weakened pathogen. And we referred to that earlier as the pathogens got those markers called antigens. They quite like that word as well, but it's a small amount, that's important. It's dead or weakened in some way, so it really can't cause us any harm. And we can refer to it as the antigen. Okay. Question 22. Why do we need a new flu vaccine each year? So it kind of links to one of the previous questions. Okay, we get the weak, the vulnerable, the people who work in maybe healthcare, that kind of thing. They can access the flu vaccine each year. We can access it if we're not in any of those categories, but we have to pay for it. And each year we have that new flu vaccine if we need it. And why is that? And the answer is because each year it mutates. Okay, so each year it becomes a new strain, and then we need to find that immunity to the new strain of the virus. Okay, hopefully that makes sense. Question 23 now. Why don't we feel ill when we're infected with a disease that we are immune to? Now, it's very easy to want to answer this with because we're immune. But what's actually happening inside our bodies when that disease reinfects us? So we are immune, we've had that disease. What happens inside our bodies when we're reinfected with the disease? And the answer is, our white blood cells make antibodies. Okay, these are the lymphocytes that do this so rapidly, really important word, the fact that they do it in a very quick way, that they fight the disease before it has a chance to make us feel unwell. So we still get infected with the disease, but our white blood cells, those memory cells, are ready for action. And they make antibodies so quickly that they're fighting the disease before we even feel any effect of the disease. Quite a key point there, okay? That's a good one. Question 24. What is the danger of overusing antibiotics? Now, some people forget that you actually get the antibiotics by being prescribed them by the doctor. So they're not an over-the-counter medicine. You can't go to a supermarket and buy them, or a chemist or a pharmacist and buy them. You have to get them from the doctor. But what is wrong, what is bad about overusing them, having lots of antibiotics in the space of, say, a year? Okay, and the answer is it causes an increase in the resistant, we might call mutated, strains of bacteria. So what's happening is we've actually got the non-resistant strain of bacteria can be killed by the antibiotics. Then there's this small colony, this small cluster of some of those bacteria that have mutated and they've become a resistant strain. They're resistant to the antibiotics. So what's happened to those is now there's no competition for resources because the other ones got killed by the antibiotics. These ones start growing, overpopulating, and kind of, increasing in quite a large scale, which obviously is not such a good thing. Okay, question 25. What do we mean by inappropriate use of antibiotics? Again, this one, it's similar, but it's not overuse. This is inappropriate use. By this, I mean, you go to the doctors, they say, yes, you've got a bacterial infection, we'll give you the antibiotics, and we want you to be on these antibiotics for 7 days. Okay, so you get your antibiotics from your prescription from the chemist, and it says, right, here's 7 days worth of antibiotics, take this many a day, blah, blah, blah. 3 days in, you feel pretty good again. And you decide you don't need to take the rest of the antibiotics because what's the point? You feel okay. Now, what does that mean is going to happen in your body? It's hard for me to know how long to pause for. Sometimes if it's a harder question, I'm pausing a bit longer. If I am going too fast, then feel free to pause as you go through. The answer to this question is, when we don't take the whole course of antibiotics, we feel better. I said that bit already, but the small amount of the remaining bacteria, so we can live with that small amount of bacteria in our body and we don't feel ill. So what happens to them if we don't kill them all is they start reproducing again. So the numbers go up and we feel poorly again. Okay, so we get to that low level where we feel okay, and then those few remaining bacteria start to reproduce again, and then we feel ill again. Okay, question 26. What kind of immunity is it when most people have had the vaccine and they protect the others? So we've had active immunity and we've had passive immunity, okay? This is where most people have the vaccine for whatever reason. A few people have not had the vaccine, but they're protected by the others. What kind of immunity is that? And the answer is herd immunity. Okay, we've heard a lot about that in recent times, people saying that if people get infected, then they'll become immune, and then there'll be lots of herd immunity and it'll protect other people, but not enough people have been infected that we have that in our current situation. Okay, question 27. Why can't antibiotics be used to treat a virus like flu? Now, if you can piece together bits from the other questions in this B3 quickfire question quiz, then you can answer this question. Why can't antibiotics be used to treat a virus like flu? And the answer is, viruses reproduce inside cells, the antibiotics can't reach them. So the antibiotics are used to kill bacteria because they float around in the blood and the antibiotics are able to access them. Those viruses, we call them the cheeky viruses, they get inside our cells to reproduce and the antibiotics cannot reach them. Okay, it's nothing to do with size, it's purely location that is the problem. Question 28. What are the cells called once a person has immunity to a disease? I've definitely used this phrase, okay? So what are the cells, we're talking about those white blood cells, called once a person has immunity to a particular disease? Okay, I want to give a clue, but if I give the clue, it is actually going to give the answer. And the answer is memory cells. Okay, they become memory cells. They remember how to make that particular antibody to fight the disease rapidly if we should be infected in the future. Moving on, question 29. Hopefully I won't say moving on again, as I say it all the time. Where does the painkiller, interesting, we've got two L's in bold and underlined there, aspirin, originate from? Where does the painkiller, aspirin, originate from? Okay, this was our weird bit where we talked about getting drugs naturally from plants. So we're looking, I think probably that double L has something to do with that. Where do we get the painkiller aspirin from? And the answer is the willow tree. Okay, so willow, two L's, painkiller, two L's. That should help us in remembering that one. Question 30. What drug originates from foxglove? Okay, glove. Glove goes over our hands. Our hands and our fingers can be called something. Again, that's another link to help us. Okay, what drug originates from foxglove? And the answer is the heart drug digitalis. Our fingers are known as our digits, and we cover our digits in a glove. That's going to be our link to help us remember. Question 31. What drug can be used to relieve symptoms but not cure the disease? What drug can be used to relieve symptoms but not cure the disease? Now this is what we call an over-the-counter drug, something that we can just go to the shop and buy. And the answer is painkillers. Okay, they relieve symptoms. You can actually write in the exam that they kill pain. It's that simple. Question 32. What is a new version of a disease called? We've said this lots of times in this quiz so far. What is a new version of a disease called? And the answer is a new strain. A new strain. Okay, question 33. We're going on to drug trials now. What is a placebo? What is a placebo? And the answer is a fake drug. Okay, so sometimes in drug trials we have some people taking the drug, some people having a fake drug. Nobody knows who's got what, and the fake drug will be an inactive version of the drug. It looks like the drug, but it's not the drug. So that means that the person might think it's the drug. You've got the phrase the placebo effect. What's the point? Why do we have the placebo? It is to compare the results. So we look at the results of all the people who've had the placebo and we compare that to the people who've had the actual drug. Okay, fake drug is a brilliant answer. Question 34. What is the first reason why we test drugs on healthy volunteers? What is the first reason we drug test on healthy volunteers? So we take healthy people, they haven't got the illness. Okay, so why do we test on those people first? What are we going to get from it? What is the first reason we drug test on healthy volunteers? Okay, and the answer is to check safety and side effects. Okay, if we've got someone who's ill, we don't want to be making them more ill by giving them a drug that's going to cause them side effects or any kind of detrimental effect to their health. Okay, so we've got the healthy volunteers to just look at side effects. Question 35. Why do we test drugs on ill patients? So we start on the healthy people, looking at side effects. We've then got two reasons why we then drug test on the ill patients. Okay, what are those two reasons that we take the drug testing to the ill patients? And the answers are to see if it works, efficacy. Okay, horrible word, it took me ages to learn how to even say it, but does the drug do the job? Does it make the person better again? And then dosage, to see what the smallest dose is that will treat the patient. Okay, so if we read on the paracetamol pack and it says take 2 of these, then we know that 2 should do the job. There's no point taking 3 because it puts us at greater risk, and if 2 does the job, why use 3? It's a waste of money, it's a waste of the drug. Okay, so the smallest dose that will treat the patient. Question 36. What is a double-blind drug trial? What is a double-blind drug trial? So we've got an open trial, a blind trial, and this is a double-blind trial, the most commonly talked about in this topic. And the answer is where neither the patients or the doctors know who has had the placebo and who has had the active drug. If we have a situation where the people who are testing the drug, the doctors, designed that drug, then they could influence the results if they knew who had had the drug and who had the placebo. So if they don't know, they can't influence, they can't bias those results. If it was made by some people and tested by an independent company, then it could be just a blind drug trial. This is where the scientists know who's had the placebo and who's had the drug, because they have no interest whether the drug passes the drug trial or not, and then just the patients don't know. Okay, so in a situation where the drug is being tested by the people who created it, it's always a double-blind trial. Neither the patients or the doctors know who's had the placebo and who has had the active drug. Question 37. Why do we do double-blind trials? Have I totally just answered this? Yes, I have. Never mind, we'll go with it, see if you remember. Okay, why do we double-blind? Why do we do double-blind trials? And the answer is, so the doctors who created the drug cannot bias, which means influence, the results of the drug trial. Okay, so the doctors who created the drug cannot bias or influence the results of the drug trial. Question 38. What kind of drug trial is it when only the drug is tested and the patients know they are taking the active drug? I've already referred to this. Okay, what kind of drug trial is it when only the drug is tested and the patient knows they are taking the active drug? And the answer is an open trial. Okay, everybody knows that everybody in the drug trial has the active drug and they're not using a placebo at all. Question 39. What is the stage of the drug trial called before testing on humans? So testing on humans is called the clinical stage of the drug trial, and before it's tested on humans, maybe looking at computer models, looking at testing on animals, what do we call, or human tissue, what do we call that part of the drug trial? And the answer is preclinical. It's the preclinical stage of the drug trial. Question 40 is the last question if you are combined science. Then we go on to the triple questions. What must happen to the results of the drug trial before the drug can be launched to the public? So we've done the drug trial, we've written up the results. We can't just say, yes, it worked, let's put the drug on the market. We must do something with it first. What do we do? And the answer is regulatory, hard word to say, review. It's reviewed by other scientists to check the benefits outweigh the risks. Okay, so there will be side effects, and we need to make sure that those side effects are worthwhile having for the benefit that the drug is going to give. Okay, benefits must outweigh the risks. So if you are a combined double science student, then you have finished today's B3 quickfire question quiz. If you're studying triple science, then we need to go on to the next 10 questions where we're going to look at some of the triple content to take us to the end of this B3 quickfire question quiz. So, question 41. What is the name of the cell produced when a lymphocyte, remember that's a white blood cell that forms antibodies, fuses with a tumour cell? So we're talking about monoclonal antibodies here. What's the name of a cell produced when that antibody forming cell fuses with a tumour cell? And the answer is a hybridoma. Like a hybrid car or a hybrid bike, it's got two features there. It's a hybridoma. It's a hybrid of the tumour cell and the lymphocyte, the antibody forming cell. Okay, we must have the oma on the end. Okay, we can't just call it a hybrid, it's a hybridoma. Question 42. What is the benefit of using a tumour cell to make hybridomas? What is the benefit of using a tumour cell to make hybridomas? And the answer is that tumour cells reproduce rapidly. Okay, so the tumour cell reproduces rapidly. We want lots of hybridomas because they're going to make our monoclonal antibodies, and we want loads of those. So the tumour cell is used because it's a fast multiplier. Question 43. Why can't we get lots of monoclonal antibodies from normal white blood cells, those lymphocytes? What's wrong with those lymphocytes that we can't get lots of monoclonal antibodies from them? Why do we go through this process of making hybridomas? And the answer is, once a white blood cell learns how to make a specific antibody, it can no longer reproduce. So we're left with this finite amount of white blood cells that can make antibodies. But if we want loads of antibodies, then cloning those antibodies, we have to turn those into hybridomas. We have to get hybridomas from our white blood cells fusing with our tumour cells, okay? So that's why we do the process. Question 44. How can monoclonal antibodies be used in the treatment of cancer? Okay, we're talking about chemotherapy here, which goes into the blood, flows through the blood, attacking the cancerous cells, but also attacking healthy tissue as well. So how can we use them, the monoclonal antibodies, to help this process, make it more effective, reduce the side effects? And the answer is radioactive isotope, okay, that's the treatment, can be attached to one end of the monoclonal antibody. And then that monoclonal antibody latches onto the tumour, so it goes through the blood. When it gets to the tumour, it latches on. It keeps that radioactive isotope close to the tumour, so it's attacking just the tumour. That means we use less of it, it means the side effects are less. It's a much more effective way of getting the treatment, that isotope, to the tumour to attack it in a local format. Okay, question 45. What is the hormone produced by pregnant women called? Okay, it's 3 letters. What is the hormone produced by pregnant women called? It's used in pregnancy test kits. It latches onto the monoclonal antibody, and that's how we get that blue line on the pregnancy test kit. And the answer is HCG. HCG. Okay, we don't need to remember the long version of that. Question 46. What causes chlorosis of a plant? Okay, so the plant isn't happy. It's probably gone less green and more yellow. Okay, and it's basically where there's not as much chlorophyll, which makes the leaves green, as they used to be. But what causes it? What is it a lack of? And the answer is a lack of magnesium. Question 47. How does a lack of nitrate affect a plant? How does a lack of nitrate affect a plant? It doesn't affect photosynthesis. Okay. And the answer is that less proteins are made because the nitrogen in nitrates goes into making proteins. It was, first of all, that nitrate goes into making amino acids. Amino acids build into big chains called proteins, and proteins are used for growth. So if there's less proteins, there will be slower growth. But you cannot say there will be slower growth. You've got to say something referring to the fact that you know that nitrate goes into amino acids, goes into proteins, and proteins are used for growth. Okay, that's what makes it triple content, is the fact that we're doing that kind of stepped process of we've gone from here to here, and we talk about how we get through those steps. Question 48. How could you identify what disease your plant has? So your plant's not looking too chipper, and you think to yourself, how do I know what is wrong with my plant? What's going to be my first go-to? Okay, quite a few answers here, possible answers. Okay, and the answers are website or gardening book. Okay, we've all got the internet close to hand these days to be able to Google this kind of thing or similar. Take it to a lab, or we could use a monoclonal antibody test. Take part of the leaf, smush it up, use it with the test, and it should tell us if it's lacking a particular nutrient or whatever. Okay. Question 49. What physical defences do plants have to resist invasion by microorganisms? What physical defences, not chemical, physical, do plants have to resist invasion by microorganisms? And the answer is cellulose cell wall. Okay, so they can't get into the cell because that cell wall is tough. Waxy cuticle on the surface of the leaf. Okay, it's good for waterproofing, but also stops the pathogens getting in. And bark which falls off the tree. Okay, so if there's microorganisms on it and the bark falls off, then it removes them with it. And our final question on today's B3 quickfire question quiz, hopefully you're still with me. What chemical defences do plants have to resist invasion by microorganisms? What chemical defences? There's two. And I'm going to go straight into those answers now. One, they produce antibacterial chemicals, so they kill the bacteria. And the other, they produce poisons, which can also deter herbivores. Okay, so antibacterial chemicals and poisons. You've been watching AQA Biology videos by Miss Taylor. Don't forget to hit subscribe. This was the B3 quickfire question quiz. Hopefully that's brushed up your knowledge and will get you fresh for all of your quick recall questions, and then using those to apply to bigger questions. Have a great day. Thank you.